Okay. Next one, we're going to discuss the relationship between conditional probabilities and unconditional probabilities. Okay? Question. Are the conditional probability always bigger than the unconditional probabilities? Let's come back to our example earlier. Given that we select an NBA player, what is the probability that this man is over 175? As discussed earlier, that chance is very good, close to 100%. Now, if we randomly select a man from Chicago, how likely the selected man is over 175 centimeter tall? Well, Caucasian male is about what? 178 to 180 what? Centimeter tall. That's average height. So select a man from Chicago taller than 175. That chance is what? Slightly bigger than 50%. I would say probably 60% or 65%. So the conditional probability is 1 and the unconditional probability is what? 0.6. Which one is bigger? Well, conditional probability is bigger than what? Unconditional probability. But can we say conditional probability always bigger than unconditional probability? Think about it, okay? Think about it. Now, next one. Let's look at this conditional probability. Given that we select an NBA player, what is the probability that he is a handsome man? Okay? Who is the most handsome NBA player? In my generation is what? Michael Jordan. Well, Michael Jordan is my hero and he's very handsome. But in your generation, probably what? Kobe Bryant, okay? Probably Kobe Bryant. But if I tell you I select an NBA player, is that guaranteed the selected man must be handsome? No. We do find one NBA player. They are actually what? Very ugly, okay? So tell me I select an NBA player. It doesn't guarantee we're going to select what? A handsome man. Actually, you tell me I select NBA player. This information is useless for what? A handsome man. Okay? Well, for example, when you select NBA player, you can have handsome men like what? Michael Jordan or Kobe Bryant, but you have also what? A lot of what? Ugly NBA player, okay? So tell me I select NBA player, it doesn't provide me any information about this person is handsome or not. And plus, handsome or not is a very subjective issue. For example, before my marriage, my wife think what? I'm a handsome man. But he changed what? Her opinion. Very quickly, okay? So, handsome or not, an NBA player are two irrelevant concepts, okay? Since you tell me I select NBA player, it tells me nothing about this person is handsome or not. So that probability probably just like what? We close our eyes, we randomly select a man from 3 and find this man is handsome, okay? So they are roughly equal. First example is greater, this example is what? Roughly equal. Now, let's look at the next example, okay? Let's look at the next comparison. Let's look at here. Given that we select an NBA player, what is the probability his annual income is less than what? $30,000. Well, you know how much they pay Yao Ming a year? Yao Ming just retired what? Just retire about not very long ago, right? End of, it's end of what? Year 2011. And I was told the company paid his last year, right? His last what? Annual income for Houston Rocky is about 15 million. Ordinary people like you and me, how can we make couple million? How can we make couple million? Well, learn from me. I buy lottery ticket, okay? So if you don't find me next week here, you know what happened to me. I retired, okay? Now, so if you tell me I select what? An NBA player. What is the probability that this man's annual income less than $30,000? That is what? Impossible. So the probability is what? Is 0. That's impossible. Okay? Now, in Chicago metropolitan area, an ordinary person annual income is about what? $40,000. Okay? About $40,000. So less than $30,000 is about what? 40%. Okay? About 40%. So which one is bigger? Well, unconditional probability is bigger. So we have 3 cases now. First is greater than. Second one is what? Equal. And the last one is less than. So what is the relationship between conditional probability and unconditional probability? The conditional probability can be what? Greater, equal, less than what? The unconditional probabilities. Okay? Now, we're going to use the example to further explain you the concept of what? Independence. Okay? To explain you the concept of independence. Definition. Definition. 2 events, A and B, are independent if the conditional probability equal to what? The unconditional probability. And they are dependent otherwise. Okay? Dependent means what? Not independent. We call A and B dependent, or you say not independent, if the conditional probability not equal to what? The unconditional probability. Okay? Now for example, NBA player and handsome man. These are 2 irrelevant concepts. Okay? So probability that given EB has occurred, we know nothing about what? The person is what? Handsome or not. If you tell me we select NBA player, but this information is irrelevant information to the man is handsome or not. So tell me this information is, well, tell me this is what? An NBA player. I know nothing about this person is handsome or not. These 2 concepts or these 2 what? Information are irrelevant. So the probability what? The conditional probability equal to what? The unconditional one. Okay? So in this case, conditional probability equal to unconditional one is what? They are what? They are independent. Okay? EC and EB are independent. On the other hand, if you tell me I select NBA player, okay? I select NBA player, and this information tell me a lot about what? The person's height. That person must be tall. So the chance that the selected person taller than 175 become very good, right? That chance is what? Is close to 1. So therefore, the conditional probability is not equal to what? The unconditional one. Okay? Because this information tell me I select NBA player, I know a lot about the person's height. Therefore, change the probability of what? A. Okay? So conditional probability is not equal to what? The unconditional probability. Okay? You want to copy? Go ahead. Okay, you want to copy? Go ahead.